The play shop, where everything is really tested and developed and tested again. We'll get over there in a second. That's a 1.2 megawatt dyno. But there's a lot to get into in here. First thing we're greeted with is actually a Gen 1 and Gen 2 Mirai. Side by side, same color. Pretty cool to see the changes over the years. I'm guessing this is a late Gen 1 because the earlier ones were, I don't know, a little bit ugly. I don't know when the facelift was, but pretty cool to see them side by side. And actually you can see how the interior has also changed, just in case you're curious. Looks, I mean, comparable, but the second Gen 1, definitely a step up. I mean, that is straight up Lexus LS vibes on a Toyota product. And over here next to the Mirais, we have some actual componentry, including kind of an opened cell. And I have Daniel here, who's a bit more subject matter on it than I am. So Daniel, what are we looking at here?
So here we've got our two different packaging options for the fuel cell module. We've got the Type 1, which you can see is shaped like a cube, and then we've got the Type 2, which is shaped more like a rectangle. What we've done is taken the entire powertrain out of the Mirai and basically put it in a box. So all you need to do as the customer is provide a high voltage connection, hydrogen, cooling, and a control signal, and the fuel cell is basically ready to go as a black box that will generate power for your electrical system.
Nice. Are these like Mirai Gen 1 or Gen 2?
These are Gen 2 systems.
Awesome. Okay.
Yeah.
And so it's like a plug and play box, more or less. People can do whatever they need to with them. What are some examples of like what people would do with them?
So we've done a variety of applications. You know, you could make a light duty vehicle with it if you wanted to. We've made heavy duty vehicles with them. We've made stationary generator demonstration projects with them. We've made various pieces of equipment at the port. You know, you could do aviation if you wanted to. There's pretty much whatever application you need a box to generate DC electrical power for.
Super cool.
Yeah.
And then what is this over here? This is like almost like an exploded view.
Yeah. So over here we've got exactly an exploded view of our fuel cell stack. This box down here is the actual stack. You can see all the cells lined up in there. So the Gen 2 system has 330 cells, and again, they're making DC power. The top portion there is what we call the FCPC, fuel cell power converter, and that actually folds down and sits on top of the stack. These are the two end terminals of the fuel cell stack. So these two connect into bus bars here, and the purpose of that is to actually boost the voltage up to 650 volts, which is the kind of nominal DC bus voltage that we tell customers to interface at. And we've also got inverters in there for some of the balance of plant components like the hydrogen recirculation pump and the water cooling pump.
Nice. So yeah, and really high level, I mean, how does this work? I guess I could see all these different like labels for like how things are done. I'm sure you could go into it forever, but really high level.
So basically you put air in and you put hydrogen in the other side, and they flow through a manifold, and then they actually flow across the face of every single cell. And in the anode, you have the hydrogen separating into a proton and electron. The proton permeates across the membrane. The electron runs through the circuitry. It meets up in the cathode with the oxygen, forms water. The water comes out of the exhaust right here. And it's basically a voltage source, just like a battery, except instead of the energy being stored in here, the energy is stored in the hydrogen, and it's converted in here into electricity.
Super cool. And then you have different wiring for monitoring all the different modules. I mean, there's like 300 and something, 330?
Exactly, yeah. We've got 330 cells, and this is the cell voltage monitor. So we're actually able to monitor the voltage of the end cells, which are the most prone to flooding.
Okay.
So we're using that as kind of an active control mechanism to make sure that everything in the stack is being maintained well. And then we're actually, within the body, we're monitoring the voltage of every other cell. So we can, again, make sure that all the conditions are being maintained properly.
Gotcha.
And that's really the key with running the fuel cell system, is you have to make sure that the stack is being well taken care of.
Yeah, and so there's kind of an ECU type thing monitoring everything.
Exactly.
And then I guess in those situations over there, if a customer is using that, I mean, how much data do they have access to, and is it up to them to do what they will with that data?
They have access to what I would say is a limited subset of data that is enough for them to use this as a black box as part of their system.
Gotcha.
This is basically standalone, and the fuel cell has its own controls. It will have its own diagnostic codes. It will protect itself. it will operate itself. The customer doesn't need to worry about how much they need to run the cooling pump, or how much airflow they need to provide, or hydrogen pressure, or humidity, or anything like that. It's all taken care of inside the box. All they need to do is tell it how much power they want to make, and that's what they get.
Nice, very cool. In the middle of this floor is this huge yard truck, or yard dog as they like to abbreviate it, or nickname it, I should say. But basically single seat, single partial cab situation, and yes, Toyota fuel cell. I can't remember if this is Mirai Gen 1 or Gen 2 stack in there, but it's just a single one. This thing doesn't need that much, power. If the gearing's right, if everything's done right, and it's also slow moving. It's just kind of a port truck. So it works at the port in like LA, and also internal to Toyota's own huge warehouses or wherever that is. But pretty cool to see all the different varieties, and I guess the actual engineers who drive this thing, who are licensed, they like how quiet it is compared to some of the diesel alternatives. So pretty cool to see this in the middle here. Not much to share beyond normal tanks and stack from a Mirai Gen 1. This thing is paired with a Toshiba battery along with that first gen Mirai system. So it gets about, 8 to 12 hours of work time before it needs to be refueled. And then, refueling doesn't take as long as it would with a huge lithium ion battery and via DC fast charging. I guess there are ways to do really fast DC fast charging with larger commercial components, but in their case, in their testing, they're trying to use the hydrogen situation. What do you guys think? Does it make more sense to use hydrogen or electric in this case? I'm looking for the answers to these questions myself, but it's curious to see Toyota's version of, hydrogen maybe works better. Here's the tanks over here on the side. All right, over here we have Cliff next to this Toyota Tundra. No, this is not hydrogen powered, but it's pretty cool to see the new Tundra put to work, in this case, carrying some, testing equipment. What do you guys do with this?
So we call this our hydrogen dispenser test apparatus, and what we use this for is going out and commissioning new stations, making sure that they're going to perform well for the customer. So what we have here is a Tundra basically with an entire hydrogen system of a Mirai in the back of the bed. So we can fill these tanks just like you would a vehicle, and at the same time we're also collecting data to ensure the station's functioning properly. Cool. The nice thing about this is that other than a vehicle you have to drive to defuel it, we can run series of tests back to back by purging this tank system without having to drive it.
Yeah, so you could fill it just like a car and then purge it and then fill it again, just like double verify?
Yes,
nice.
Exactly.
And then I guess an example you guys mentioned earlier is like, also by this being a normal truck, not a fuel cell truck, it's like if a station has a serious issue, you're not relying on that to get you home.
Exactly. Yeah, if there's like contamination or impurities, something like that could happen. But yeah,
super cool.
It's a useful tool for us. It's makes testing stations much easier and quicker.
So you can test stations. Do you use it to like commission stations?
New stations that come online that are just newly built, we'll use this to make sure that they're following the SAE protocol when it comes to fueling.
Nice, very cool. Thanks.